This is the eiConsole, an integrated development environment for building, deploying, maintaining, and testing integration interfaces. When you first start the eiConsole, you're shown this route file management dialog, which shows you a currently selected working directory, synonymous to the project folder, and all the interfaces that currently exist within there. PilotFish is being leveraged in virtually every area of healthcare. Here we have a selection of demo interfaces that are loosely based on actual client implementations. Today we'll take a look at Interface 8, EHR Integration. When you open an interface, you're shown the main eiConsole screen. This table here represents the topography, the workflow of the interface. It's organized into rows and columns within this table. Each row on the left represents a source system, so here we have 2 source systems. Each row on the right represents a target system, 2 target systems, and each of the 7 columns represents one of the 7 stages in our assembly line approach to building interfaces. Users start by adding as many sources or as many targets as they'd like, moving left to right configuring a source system, which stores information about the system you're connecting to, a listener to actually pull information from that source system, a source transform, since each source system might be providing you data in a different format, the job of the source transform is to turn it to a common representation, a routing stage responsible for determining which target systems a given message goes to, a target transform, for each target system that might need a different format or representation of the same data, a transport for sending the data out, and a target system to describe what the name and information about that system might be. After adding your sources and targets, you'll start with the first stage, source system. First stage, source system, is a place to provide a system name. You can also choose an icon that best represents what system it is you're connecting to. The second stage, listener, is where you'll actually decide how to get information from that source system. You do that by selecting a listener type from this drop-down here. So you could pull a database, directory, email, FTP, lots of flavors of HTTP, queues, and more esoteric means. If you can think of a way to send or receive data, there's a listener available. After you've selected a listener type, you'll simply provide some configuration item information down here. So our first source system is accepting CSV files in a directory. Our second one is accepting EDI files coming in over FTP. After a listener accepts or creates a transaction, it will move left to right through each of the subsequent stages in your interface. The first set of stages it'll go through are processors. Processors perform high-level operations on data right after it comes in the system or right before it goes out. This can be things like decryption, character conversion, compression, which ship with quite a few processors available. Each source system has a source transform associated with it. The job of the source system is to take whatever particular source system provided and convert it to a common representation of that data, so that by the time it reaches this routing stage, all of your data is in the same format. This happens in 2 parts. The first pair is a transformation module to take any non-XML format and convert it to XML. This could be something as simple as a CSV, a delimited fixed-width file like a COBOL copybook or terminal scrape, the EDI, those are the 837s, 834s, etc., HL7 2.x, JSON, Microsoft Excel, or if you know you're receiving XML already, such as the CDAs, CCDAs, or the FHIR standard, you'd choose no transformation. The second step is an XSLT transformation to convert the XML you've received or created into your common format. We'll revisit this stage a little bit later on the target side to demonstrate how we convert to an HL7 XML representation. The next stage is the routing stage. The job of the routing stage is twofold. The first is to determine which of your target systems a given message is going to go to. That can be all targets. You can do round-robin load balancing between multiple systems, or you can set up arbitrarily complex expressions and route on the content or metadata about a message. The second job of the routing stage is to determine what happens in the event of an error. You do that by defining transaction monitors. Transaction monitors listen for errors anywhere in the interface you've defined. That can be something as simple as sending an email, or you can set up an entire workflow and treat your error like any other kind of transaction. And that will enable you to handle that error in any way you can conceive of. When a message enters a target, we reverse the same order of operations we did for a given source system. So there's a transformation here to convert the XML canonical representation to different XML format, and then a transformation module to convert that to any non-XML representation. The tool we use for building out these transformations is our data mapper. We'll open this up for our HL7 2.x transform. This is a 3-pane mapping tool. On the left-hand side, we have our source format, what you're mapping from. In this case, our common representation is just representing some basic patient information. So for our 2 source systems, we've just provided out patient data. On the right-hand side, you have your target format. This is what you're mapping to. In this case, we've loaded the entire HL7 2.x standard, and we're mapping to an ADT A01 feed. In the center panel, you have your actual mapping logic. You build out this mapping by dragging and dropping from your source and target format into this panel here. Up at the top, you have a palette of all of your XSLT and XPath functions. These allow you to do conditions, iteration, flow control, and really anything else you need to facilitate mapping. The reason we have this third panel in the center here for facilitating these mappings is that we find it grows well and scales as mapping complexity increases. What a lot of tools will do is give you a left-hand side, a right-hand side, and have you drag lines between them. And that works great for a few fields, maybe a dozen, even a demo, but once you have hundreds of fields, you have repetition, all of the logic that's part of a real-life mapping, that model breaks down very, very quickly. For our tool, this tree just happens to get a little bit longer. Working with the center panel is just a matter of dragging and dropping. So what we'll do is we'll take our PID5, the patient name, take family name here, the last name, and just delete that node. So click delete. On the right-hand side, if we navigate down to the same field, we'll see that this doesn't have the check mark like some of the others do, and it's not italicized. So right off the bat, the data mapper will tell you what fields you have and have not mapped. To recreate that, we can just drag this element onto its parent. So we'll drag this onto PID5 patient name, and it's going to put it in the correct order. And now you just have to make a determination as to how you're going to populate that particular field. You've got this tool palette up here if you need to do some kind of code call out or other way to augment that data. We could hard code it, or if we want to populate it from our source system, we can just take last name and drag it onto XPN1. Underneath, this is producing and consuming W3C comply XSLT. So we can see the XSLT tag that was created by dragging and dropping that here. Now, this is a fully featured code editor. Any changes you make here will show up in the UI and vice versa. It has auto-completion and all the other things you would expect, but you never have to drop down into this view. The only reason we show it is to demonstrate this is, again, W3C comply XSLT. There's nothing proprietary about the transformation logic being used here. Also featured within the data mapper is a fully featured testing facility. So you can switch this testing tab, provide a source sample, push a button, and see the output. There's also a debugger for doing this step by step to see exactly what's going on at each stage of that transformation. When you first open up a mapping, you'll usually start by defining your source and target formats. You can do that by clicking this button and its corresponding button on the source side. You'll choose a format reader. This can be something like DICOM, EDI, flat files, HL7. You can read directly from a database or a SOAP service. In this case, we'll choose the HL7 2.x. And you can see we'll provide an HL7 version, and we can even limit it by message type. When you're using the built-in format readers for HL7, EDI, and some of the other standards, what these will provide is friendly naming within the data mapper. So we know, for example, that PID5 is patient name and XPN1 underneath there is family name. Anywhere HL7 or another standards organization has provided information, that will be inline as well. The example of coded values like PID8, you'll see those in a code tab, so you don't even need to refer to external documentation to work with these different formats. Some other features within the data mapper: you have the ability to search, extend, and sort through the different formats on the left and right. You can even do schema slicing and export these to a schema. There's a built-in differencing engine to allow you to facilitate mappings between different versions. So if you need to map from HL7 2.5 to 2.6, you could push a button, it would generate the mapping, you just need to make some adjustments. Another useful aspect of the data mapper is that any of the transformations you build in here are inherently reusable. You can import other mappings from within here, or use this one in another transformation. That's the data mapper at a high-level view. And one more thing we'll stress here is that this is the same tool that's going to be used regardless of what your source or target system is. So if you're mapping from a database to HL7 to HL7 to FHIR, from an Excel file to a PDF, you'd use this data mapper in every single case. You don't need to learn different tools for every single standard you come across. After we've completed our mapping, we've configured a transformation module here to take that XML representation of HL7 and convert it to the actual HL7 delimited file. The next step is to define a transport. The job of the transport, like the listener, is to determine how data is going to be sent out. You also have a chain of processes available if you need to encrypt, compress, or otherwise do some manipulation of that data before it reaches the transport stage. If you can think of a way to send or receive data, there's a transport available. So our first target system here is going to be doing an HTTP post to a particular URL, whereas our second one is going to be sending an HL7 message over the MLOP. The last stage is to define a target system. Like the source system, you'll provide a name, and you have the ability again to choose an icon that best represents that system. After you've configured your interface moving left to right following our assembly line approach, you'll test it. To test, you just have to go to Route and switch to testing mode. There's no compilation or deployment, and you can start your test from anywhere within here. What we'll do in this particular case is go to our source transform, click Start Test here, and provide a sample file that represents the data at that point. So here we'll choose that we're taking our data from a file, and we'll provide this test.csv sample. Then you go up and push execute test. As each stage successfully completes, you'll get a green check mark telling you that the stage has exceeded, and a red X for any failures. You can then view the transaction and how each stage affects it. So we can view our original CSV we provided it. This delimited and fixed width file transformation converts that CSV to an XML representation. Here we've pulled out some basic patient information and a mapping that we defined but didn't walk through. And then for each of my target systems, these are configured to generate that data in a different format. So we have the first transform defining a FHIR transaction, and our second, the one we walked through, shows us the HL7 2.x result of that transform. And then lastly, for any of these transports that failed, we can open this up and get some more information about why that particular system wasn't able to be reached. So in this case, we have a 404, meaning we couldn't reach that particular target system. After you've completed your testing, you can return to the file management dialog and make a determination as to what you'd like to do with that interface. You can take the directory where it's stored and check that into a source repository like svn, get, or sourcesafe. All of our configurations are stored in plain text, XML, and folders. You can connect up to the EI platform server, drag and drop and hot deploy it to be running immediately, or you can share it on our PilotFish Interface Exchange, a sort of app store for interfaces. If you're a vendor and you'd like to provide an interface to your clients or users, you can very easily share that on the PilotFish Interface Exchange and they can use and download it. After you've deployed an interface, you can monitor it using our EI dashboard. The dashboard provides an operational view of all interfaces running on the EI platform and real-time statistics for transaction throughput and health. Administrators can manage and monitor all aspects of the integration platform via the EI dashboard. If you're a solutions provider, you can also return to the file management dialog to duplicate, modify, or tweak interfaces or interface templates. Thanks for watching this demonstration of the EI console for healthcare.